Okay, good morning, everybody. I think we have more than enough participants right now, but we're gonna get another few more minutes to see if there's anybody else joining. Just let me know if you can see my screen. Can you see the presentation right now? Good. Screen. Okay. Okay. Perfect. I can see some responses. That's very well. Okay, so good morning, everybody. My name is Michael Tsudikov, and I'm the sales director for Opgal Electronic Industries. With me here today, Dr. Hashmonay, who's our Chief Science Officer, and together today we're more than excited to give you this wonderful webinar where we're going to talk about detection and quantification of methane for both OGMP and other regulatory compliance frameworks. So let's start. Yep.
Yeah.
You want to say hi?
Hi.
Perfect. Great. We're going to launch the camera so you guys could see us as well. Okay. Let's do it. So, few words about Opgal and what we're doing and how we do that. So, basically, Opgal is a global leader in manufacturing thermal imaging devices for the last 40 years. We've been driving the technology to different angles, and we have more than 50 years right now focusing and concentrating on OGI cameras and OGI solutions. So by far, the 15 years of experience is actually giving us the authority to have this webinar and to talk about that. Few words about where we're located and what we do. So we presented globally, and you can see the map. So the map is actually coloring more than 50 countries where Opgal presence is existing. It covers over 6 continents. We work directly through to the end users. We work with our channel partners, with our exclusive representation worldwide, and it actually allows us to reach to most of the customers and just give you some of them. You can find here the list from different continents, from different areas, from Latin America to North America to Europe, to Middle East to Asia, of course, and what we offer our customers is basically the following solutions. We have the 3 types of our devices. The one is the handheld devices, which most of you are probably familiar with. We have the fixed monitoring systems, which allows us to detect or to monitor sites. We have the airborne or the flying, the camera, which is connected to the flying platform. And we have the dedicated apps and software which helps us to quantify and actually to visualize the gas. So in a few words, slight reminder about the handheld solutions is as following. So we have the IC-Gas Multi, which is the cooled OGI camera, by far the best performed. We have in the widest operation envelope for Appendix K and the European requirements. It's the cooled mid-wave infrared camera. It detects methane, of course, in over 400 different VOCs. We have a patented special spectral filter technology built in. It's the most sensitive camera in the industry by far. It can detect methane with with the sensitivity of 0.35 grams per hour with a delta T of 2 degrees Celsius. We're EPA Quad OA, Quad OB, and Quad OC compliant. Of course, it's absolutely intrinsically safe equipment. It has a lot of features. We have the highest battery time and a lot of perks, which we like free firmware, so there is no need for annual calibration. The self-calibration feature, which we issued in the last software release of the IC-Gas camera. So basically all of that making it a very valuable tools for most of our customers, where they want to have a reliable equipment and with an affordable access to it. Recently, we presented an ICGAS app with two versions, both for Android and iOS. It allows you the wireless connection, remotely viewing the camera and taking control of a camera. You can just set up your device on a tripod and actually switch when you have those hard-reaching locations where you need to hold the camera, or you're not capable of doing that, or where there is not enough space, so you can use the app. It actually, the most of the major benefits of that app is actually that allows you to record and capture images and share it directly from your device to WhatsApp through other social media. And you can share the videos and the process of the inspection can be easily shared with other users. Of course,
anywhere.
Absolutely, anywhere, exactly. So the next features, you can actually stream your video to remote locations. And what we are planning to add to the new version of the app is one of them, I would say, the most exciting thing, which we can have the quantification capability and plume coloring all together built in the app. So you would see all of those features upcoming in the next release. Moreover, we can share the video line, or actually you can share the inspection process online with some other users that will be sitting. Let's say you are in Europe and there is another user that you want to share your inspection within, let's say, Uzbekistan, for instance, right? So you can do that easily. And that's one of the more interesting and more, let's say, valuable features that we added. Of course, there is new surprises, but we're not going to talk about it right now. We're going to keep a little bit for the release date, but that's an overall about the app. But as I mentioned, it will be coming to both platforms, to Android and iOS. As you know, we recently, not recently, year and a half, almost 2 years ago, we issued the first version of our built-in quantification feature. Actually, we updated it a couple of times. There is another release upcoming for the newer version with more advanced capabilities. So it allows you to make the measurement of the concentration and actually cut the mass flow out of those measurements. And get in a real time, you can get the numbers. You can also, there will be a special feature to save QOGI files in combination to the built-in quantification feature for the post-analysis processing and for the validation process, which is let's say, one of the most demanded requests today to validate the videos and validate the inspections. So there are multiple compounds. Again, we created a drop list at the camera software where you can easily pick your compound whenever it's methane or propane or butane or whatever. The most prominent ones are added to that list. So that could be easily picked up. So basically, it's as if from those who already use that, you would say that it's a very user-friendly interface. It's very intuitive, so you can set up your inspection very fast. And it will allow you to save the videos with the reports, of course, and with, as I mentioned previously, the QOGI files, which will be recorded simultaneously to the MP4 file at the same process. And from that moment on, I will just leave the most scientific and the most interesting part to Ram. And Dr. Hashmonay, please take over.
Hello, everybody. I will dig into more explanation about our QOGI and how it is used in the regulatory frameworks, like in Europe, the US, and also for the global OGMP 2.0, which is the oil and gas methane partnership. One of the things that OGI quantification is a complex software, but it's also a complex data collection process that needs to be verified. If you don't do it properly, probably the software will give you inaccurate results. And we are focusing on training these days and validating the results before our clients will report their results. And we are working back and forth, and that's why we added the feature of saving the data file for the quantification, so we can do post-analysis and validate the results before our clients report it to the authorities. So just a slide for explanation. What is OGI and how it detects and how it measures concentration that are then transitioned into the mass flow emission rates or leak rates. So OGI is a thermal camera, and it actually measures the temperature of the background or the radiance coming from the background surface. So each pixel is assigned a temperature. So if you don't have a cloud in between, the temperature will not be impacted by the atmosphere. But once you have a cloud of gas coming in, it's either reduce the energy, reducing the temperature, or adding to the temperature that you see in each pixel. And this changes in temperatures in each pixel where the gas present is what we see and detect. But the amount of the energy reduction and the amount of addition is proportional to concentration. And we have a unique way to quantify concentration, what we call concentration length, which is the product of concentration time, the plume depth. So just to explain the emission reduction, if the background is warmer than the gas plume or the air around the gas plume, we will see an absorption, we will see a reduction of the temperature that we see in the image. But if the background is warmer, like in the sky background, we will see an addition to the gas temperature. And then anyway, we'll see a change that is very visible. We are trying in this equation, we are actually measuring contrast that is normalized to the delta T, to the temperature difference between the background and the air. And we are quantify it to the response for a specific gas to specific filter of the camera, and we can retrieve the concentration length for each pixel. I'll do it. Sorry. So I just explained how we retrieve the concentration length for each pixel, but in order to get the mass flow, leak rate, or the other units of volumetric flow, we will need to do a summation of concentration through a vertical plane downwind from the plume, and we will have to consider the wind speed in order the product of the wind speed and the integrated concentration in the plane downwind will give us the mass flow leak rate. So this is just an example how it works in our software. Just wave if you can see the video moving, because it's really important. Okay, that's good. So we can see a couple of vents venting, and we are 100 meters away here. And you can see the warm building, the warm background building, creating a black cloud, which is temperature reduction. We can see the temperature reduction. And if you see the plume go on the sky background, which is colder, it will turn into a white plume over here. That means it's the plume is warmer than the background, so it turns into white. So this is just an example what I meant in this complicated equation and in diagram.
You can have it.
Okay, so What it does, and I'll show you, I'll take them out of here. What it does, it's actually it's quantifying CL in a line of pixel downwind from this plume, integrate them and consider some the movement of the plume to retrieve wind speed, and eventually it will give you the leak rate down there. You can see the leak rate over there is almost 20 kilogram per hour, and it also calculates the average ppm inside the plume. And now the cloud is standing, so you could see that the concentration going to zero on the left side. Concentration when the plume is going below the plane of measurement or to the other side, the quantification, now it's going down, so probably maybe it will be zero. I'm not sure. But anyhow, it's really measuring the concentration and the mass flow. And at times that you have a measurement that gets zero, it's not including in the average quantification. So that's very important to know. I think it will go now to zero because it's going down. Yeah, now it's going down, it will go to zero. You see, it's going to zero. The flux is going to zero, but these zero numbers are not included in the quantification average for the time of the analysis. So I'm going to talk about a little bit about detection, about the new US EPA and EU Parliament new rules and regulations about LDAR, leak detection and reporting and repair programs. And I have a table here of comparisons. So in the US, they are focusing on the OGI technology as the required technology to detect leaks instead of sniffers that were like method 21. And they published in the end of this regulation in 2024, they published Appendix K. It's the last 15 pages of this regulation. And Appendix K is actually the method how you conduct an LDAR and which technology can be included and what envelope of performance is required to do these LDAR programs. And in EU regulation, they have not a specified technology. Any technology that can measure methane in a certain level, above a certain threshold is if you can prove that it can detect it, it's acceptable for doing LDAR programs. So the US is focusing on methane and seas as well, not just on methane. This Appendix K regulation is driven by methane emissions, but it's not solely. It's about VOCs and air toxics emission as well. So everything is for methane, and you have thresholds to other VOCs expressed or represented by butane and propane, and they have different thresholds here for leak detection and repair for the camera. And in the EU, they are driven by methane, and they are focusing on different type of LDAR surveys. The most common one is the regular LDAR survey, and then they have 17 gram per hour threshold. So any technology that can measure, not just OGI, 17 gram per hour can do these type 1 LDAR surveys. And the important for OGI technology is to determine what is the envelope of performance, what are the conditions that you need to have in order to go out with OGI technology and do the survey. And this is specified in Appendix K of the US regulation. They require each vendor or each user to develop the performance envelope expressed as what are the wind speeds and distances and delta T's that you can go out and do the survey. So Opgal developed this IC gas multi-performance envelope for the Appendix K. So you can see that it's expressed at, we have a distance, we have two distances and two temperature difference. We have temperature difference of 5 degrees, so we are more sensitive in this, so we allow ourselves to go in much stronger wind speeds and do the survey. In 3 meters and delta T of 5 degrees between the background and the air, we can go to winds up to 11 meters per second and still measure 19 grams per hour of methane. But if we have lower delta T, lower than 2 degrees, like almost ambient delta T, we can do this with almost 8 meters per second. And you can see what are the distances. When we are going to longer distances, obviously the wind speeds are going down, that we can do the survey if the sources are more distant. So this is the performance envelope for the Appendix K. And the European actually set up 3 thresholds to 2 types of LDAR surveys. Type 1, it requires a minimum detection leak rate of 17 grams per hour. And based on a third-party study that we did in France for Xera, with Xera, we can measure with ambient delta T up to wind speed of 7 meters per second, this 17 grams per hour. So in Europe, we can use OGI for leak detection in days that are 7 meters per second and below. That's in the case where we are doing surveys from close by, but if we have actually larger delta T and sky background, we can use higher wind speeds. And for the other type, there are some of them are ground level. We have 5, and some of them are offshore. We need to consider the wind speeds. It's 5 and 3 meters per second on average. Okay, so I'm going to introduce the role of our QOGI in the OGMP framework, the Oil and Gas Methane Partnership 2.0, which is the UN program that already more than 150 membership partners joined in the last couple of years. And what is important here, which is it's a framework for reporting your sites or assets emissions, which are measurement based. And there are two levels of measurement based reporting under the OGMP. We have level 4, which is the bottom up source level emission. I don't know if you can see it, it's really small, but and level 5 is the site level. We call it top down. And in order to report it, you need to have at least 70% of your emissions. You can see the orange rectangle on the top here. 70% of your emissions need to be quantified at source level. And then you need to do some site level measurements and reconcile the uncertainty before you report your site level 5 emissions for each of your assets. You can do more of 70% and less of the site level, but you need to reconcile. Either way, you need to reconcile. You cannot do just site level 5 top-down measurements and not consider the summation of your level 4 emissions. So what's important here, what I just said about this is text, it's non-prescriptive. The operator can use any technology that will give him a better process reconciliation and smaller uncertainty in the reconciliation process. So, but it's saying, this is text from the OGP. So it's saying it's a build-up experience. It's a circular experience that from year to year you are supposed to get better in your reconciliation between level 4 source level emission quantification and site level quantification. So you're learning from the process, but it says that the operators should focus their most robust measurement efforts on reducing uncertainty associated with larger emission sources. And this is a very important point that I have in this webinar, that from our experience, these major sources in each of these upstream and midstream sources are line up with inaccessible and remote sources, that not small leaks that are close to the ground. And these are the most difficult to quantify. And what we have here, we have a video here, that this is a vent that we take remotely. It's a huge leak. I will not say how much it is, but of natural gas. And these on the sky background are difficult to quantify because sometimes you have clouds in the background, and we address this very accurately. We can actually do quantification on varying sky background. And most of the time, a couple of vents or even one vent in one asset will be more than 70% of the operator or the site owner emissions. So you can focus on very small leaks with iFlow sampler, and you can sum them up, but they will never get to the 70% of your emissions, because if you have one vent that emits kilograms per hour, and you have small leaks that are 10 grams per hour or 100 grams per hour, it's most important to do the quantification of these vents accurately. So this is what we have been focused the research and development in the last year. And here's,
sorry, Dr. Ram. There was a question about the maximum distance of our cap. Just popped up. I'm sorry.
Okay. There was a question. There is no maximum distance. For detection, there is no maximum distance. In some cases, we just last month we measured 4 kilometers away. A few years ago, we had a vent, offshore vents, 10 kilometers away. It really depends on the delta T, as I explained, and the size of the emission that we can see. But for quantification, we are tending to be 100 meter, something like this, 100, 150 meters. This is the maximum distance. So let me, you can see the presentation? What to do?
That's good. Close it. No, yeah.
Okay, I'm being distracted here.
Sorry.
So we participated in two-phase European Gas Research Group, GER group, studies. The first one was a blind testing, and part of it was vents, remote vents, inaccessible vents quantification. And there are 10 companies participated, and this is already published, and we mentioned it in past webinars, but I want to drive a different point showing this. So the top 5 graphs are site level technologies, and the bottom 5 I will answer.
Yeah, we'll have the question session just after the presentation. So
Yeah.
just keep your questions with you, and we'll have dedicated time for the question. Thank you.
Yeah. Okay. And the bottom 5 graphs are bottom-up source level emission quantification, and you can see that the 3 middle ones with the ellipse around them are OGI technology, QOGI technology, and the center one is ours. And you can see that the larger emissions are all vents. The emissions that are in the ellipsoid are all vents and remote. And you can see that our quantification was the closest to the red line and inside this ellipsoid, and this OGI technology is overestimating and this OGI technology is underestimating. And the one on the right over here is the iFlow sampler that cannot take the vents at all. It just took the small leaks around the ground. So the QOGI and our QOGI is almost the best technology available for doing good quantification, accurate quantification of these remote, inaccessible emission points. For some reason.
Yeah.
So after this study in 2021, we had a follow-up study, phase 2 of this, and this was a site-level methane emission reconciliation that the site owners knew, the GERG organization really knew each of the leak quantified point and also the site level in 2 different modes of operation. They divided the compressor station site into different areas. And you can see this is our Opgal. They had helicopters with laser, they had tracer release, they had LDARs, they had point monitors, they had iFlow samplers, they had all kind of technology, continuous top-down flyovers, and bottom-up. On the bottom-up source level, there had only 2 technologies. Opgal's QOGI that was selected because of the success of the first project, and the iFlow samplers that took 30 leaks, very small leaks. And you can see on the top down, they have 6 technologies and the continuous monitoring and other 2 technologies. These are all site level technologies. And each of these technologies, this report is not open to the public, but I can share our results compared to the other without mentioning names. You can see these are the 7 technologies that reported, and it goes area by area. So you can see reported almost the largest number of leaks and emission points that we detected. We first had to detect the leaks, find the leaks, and then quantify them. And we achieved 100% reconciliation by area. And then on the site level reconciliation, in 2 modes of operation. One, when the compressor doesn't work, mode 1, and when the compressor is in operation, it's called mode 2. And you can see that also on the site level, summation of all our point measurement reconciled very nicely with the site level. So to summarize this, our QOGI technology has dealt in the last few years with very difficult task of dealing with taking the remote vents and remote and inaccessible emission sources and large sources and major sources. We can quantify up to hundreds of kilograms per hour with our, not just I will do the movie when I get to this point. And we've dealt with distance and atmosphere corrections, and we've dealt with varying background conditions. And this is an example of something that we late last year we measured with our quantification. You can see there is a plume over here, and it will start in a few seconds to quantify it. You can see the quantification is about 1 kilogram per hour. It's very stable. And now when they will shut it off, and what you will see, it will go back to 0, and then clouds will come in, and it's not showing anything. So they're shutting it off, it's going to 0. Now clouds will come into the measurement plane, and nothing, it's not responding. It's not responding to the clouds. And that's what we did to differentiate clouds in the background from and then it's coming back, they open it up and back to about 1 kilogram per hour quantification. You want to add something?
Yeah, that's a very good, thank you, Dr. Ram. That's a very good differential point, because normally all of the other existing QOGI technologies are struggling to misreport the clouds or the ambient conditions, such as and they will report it as a false positive. So you will actually have a readings with clouds.
Or then this is explaining this graph over here, the other OGI, because all of these vents were on sky background, and some of these days had clouds. So this case, the one to the left, the second from the right over here, is the overestimating, probably have clouds in, and the other OGI, QOGI severely underestimate all the vents. And actually, the large vent over here, both are not even reporting. They couldn't take it because it was too far away and too big of a leak. And our QOGI can deal with the sky background and take the accurate measurement of the vents. And I'll go back to the summary. Oh, sorry, this is the summary? No. Sorry. So it has been proven to be accurate, and that's where we see the most strengths in level 4 major sources that are remote and inaccessible. It happened to be that these inaccessible and remote are also larger sources of emissions, and therefore the operator should focus, like the OGMP documents states, that focus on these major sources more than 70%, and accurate quantification of these sources will give him easy reconciliation with site level emissions and be part of this whole framework of reporting OGMP. And I think you have something else to say for summer?
I think thank you, Dr. Hashmonay. Thank you for your interesting lecture here. And as a part of this webinar, the idea here is actually to show the capabilities and to show the advantages of using proper OGI or QOGI technology for your reports. In that case, where you...
I want to mention another thing. We just added the feature. Before, the quantification would save the real-time videos and you have the quantification report. But now we have in our new firmware that we are going to release shortly, we're going to have a way, it's going to save automatically also the data file that you can send it to us in case you have some issues with your quantification, and we can give you feedback. We can validate your results, or tells you how you did the citation, if you have enough delta T, if your estimate of wind speed is right. We can start a process of online training and feedback for you guys to do, because major part of doing QOGI is the user. It's not just the software. You can have very good software with a bad user, or not very well, not bad, he's not bad, but he's less trained user, and you would get wrong results, and we start a process that you can send us back your data files for each quantification, and we can give you feedback how to do it next time better way to get more accurate quantification by yourself. So this is we have some questions.
So thank you, everybody. I think that's the time for the Q&A session. So you can please use your chat and actually direct your question either to Michael, either to Dr. Hashmonay, either to both of us, and we can actually reply on that. So
yeah. Can you also go through stationary camera features, please? We have one camera here installed around the refinery over here. And when I said last week that we measured 4 kilometers away, we detected emissions. We used it's a fixed camera that we use over there. We recently are revising the approach on our fixed camera. We are going to integrate sensors and monitors that are on site, maybe by the client. We're going to connect to them and use some of this information to trigger or to send alerts. And then the camera will give you the evidence where it's coming from. As I mentioned, it's very hard to quantify if you don't know the content of the plume, because OGI is not speciating. So we are using some ancillary information from sensors and monitors, and we will do much better quantification from the system.
So what is the verified accuracy rate for the quantification?
The verified, it really depends on what we're talking about, but we are updated the way we report the uncertainty for each quantification. And sometimes in different conditions, Michael here came to me frustrated. He said, why is the uncertainty is 100%? So I said to him, because something is not very good in the data collection and the software will pick it up. But most of the time it's below 25 or 30% the uncertainty for the quantification. And if you do it right and you do it long enough and you have enough delta T, you can go down to 10 to 15% uncertainty.
Yeah, but I want to emphasize another thing, that this is an uncertainty. It's not accuracy, right? So that's something that we are not sure for the last, let's say, 10% that you mentioned. For the last 10% could be higher or a lower value. But yet again, to be on the safe side, we would report the final result with a certain number of uncertainty that, again, could be on the top and on the bottom of that particular number. So will you be sharing the presentation after the webinar? I don't know, maybe.
Yes,
maybe.
Yes, we are sharing it.
Okay, so please, ladies and gentlemen, any further questions, we'll be happy to have those. There's one question from Dauren. Dauren, I guess he's from Kazakhstan. So could you please advise on LDAR type 1 and LDAR type 2 differences? You will have to go back to the LDAR specification.
I will have to go back and remind myself what is included. I remember that it's inside the regulation, the LDAR types, but most assets and leaks and pipes are LDAR type 1. And just a second. And type 2, there are one of them, I think, is offshore, some of maybe ground emissions, but most common, 95% of LDAR types are type 1. Type 2 are very unique cases that you want to see it from the ground or on the offshore maybe underwater, I don't know. But I'm not an expert on these types, but you can go and read in. We can share with you the information later.
Okay, so we have another question from Mukhtar. He's asking, what is the cost of the handheld device? Well, that's something you have to address to your local dealer or the local representative. And if you're not sure who is your local representative, you can drop me an email to michael.t@opgal.com, and we will directly to the person who is in charge of the region or the channel partners, because we have channel partners mostly all over the world, and every region has one. So you can find us easily. We have one that is presented us in Africa's Alpha Designs, for instance. They have a presentation all over the Western and Eastern Africas. We have in Europe several representatives, in Central Asia, in Far East Asia, in Korea. So basically all over the world is covered. So you just need to find one and drop me an email and I will redirect you. So thank you very much for the presentation and Q&A session. Perfect. Thank you. Thank you very much. So, gentlemen, anyone else want to address any particular question? Few moments to let the people type down the questions.
I'm addressing the question that so this is a type of the fixed camera of coloring that it will do when it detects remote emissions.
There's another request for technical questions. Well, basically, for technical question, you can ask us directly, or you can go to your representative. It's equal. Basically, they are skilled enough to reply on everything. What is your best advice for easy compliance to OGMP 2.0?
It's a big question. It's a very open question, but talk to us and we direct you to some consulting firm. The best advice, do the major sources with QOGI, with our QOGI for level 4 quantification. This is the best advice that I can give you, because otherwise you'll go around and will never reconcile the small leaks that you take with the iFlow sampler with the site emissions. And until you quantify accurately your vents and larger sources, you will not reconcile with site level emissions. So
can I suggest data integrate with the third-party analytic platforms for automated LDAR reporting? Yeah. So yeah, it's absolutely can be switched. For instance, we have a very good reporting tool with our partner in Uzbekistan. They're using a bot that actually goes through the reports and gives you the best analysis and throw the data very easily, so you don't have to go and sit with the tables. So it's very convenient and very you can go and ask Hashmonay Energy, for instance, in that case, so that how they do that. And
I think also in the US, and we connected to several providers of LDAR tools and LDAR programs in Canada, in Europe, in the US, and in Europe. So it's possible.
Okay, is the technical possibility of upgrade to the newest version? Gregor, I guess if it's possible to upgrade to the newest version of Gen 1, no, unfortunately, it's not possible any longer. We do not, it's a very old product, so I guess that's something you should also address to your local channel partner, and we can discuss it, how maybe we can get you a better deal, or get you get your hands on some device that could be somehow offered. Let's say it will be more affordable for you. Okay, so gentlemen and ladies, I guess that's about time. We are going to shut down the webinar, and we're going to enjoy some coffee. And I guess it was a very long one for you. So the last question, if you want, if not, we're just going to close this session and we'll update you on the next one. Okay. So
have a good day wherever you are.
So thanks everybody for joining. There were people from all over the world joined this webinar, and I'm very thankful for you that you dedicated our time and share with us your time, and we will be more than happy to share our knowledge with you and our technology to provide it to your end users or to your company. So thank you very much for joining, and have a great, wonderful day. Thank you.